All right, in this chapter, we're studying applications of the derivative. Our first application is sort of a gentle introduction to just applying the derivative because we're just going to kind of build on what we already know. Our first introduction to the derivative was to help us find the slope of a tangent line. So what we're going to do in this section is just kind of finish out that process and say, okay, well, maybe we know the slope of the tangent line. Can we find the equation of the line itself? And then we will also look at normal lines. And a normal line is just one that is perpendicular to the tangent line. So we use perpendicular as a word when we describe two lines. When we talk about a line's relationship to a curve, we use the word normal. So we say a line is normal to a curve if it is perpendicular to the tangent line at that point. So the problems kind of come in a couple different varieties. Our first type of problem, this is a pretty straightforward question. They say find the equation of the line tangent to the parabola y equals x squared minus 1 at the point negative 2, 3. So they give us the curve, right? We know the curve that we're working with, that we're interested in. We know that we're looking for a line that's tangent. They'll tell us whether we want a tangent line or a normal line. And then here's our point. Now we want an equation of a line. And to get the equation of a line, we need the slope and we need a point that that line goes through. So they've given us the point. We're going to use calculus to find the slope. So our curve is y equals x squared minus 1. A slope of a tangent line is given by the derivative. So dy dx is equal to 2x. And our slope, our m tan, we're just going to evaluate dy dx at the point. And we only need the x coordinate here. So this is 2 times negative 2, and we get negative 4. So there's our tangent slope. And then let's find the equation of the line. When I find the equation of a line, when I'm looking to get the equation of a line, I always just use the point slope form. So that's y minus y1 equals m times x minus x1. When I know a point that's on the line and I know the slope, this is sort of the easiest thing to use. So my x1, y1, that's the point they gave us, negative 2, 3. So here we have y minus 3 equals, our slope m is negative 4. X minus a negative 2, well, that's x plus 2. Now, they don't tell us to write it in slope-intercept form or general form. You know, they don't tell us how they want it. So really, you could leave it either way. If you wanted, you could leave it in this point-slope form, or a lot of people like to get it in slope-intercept form. So I'm going to distribute that 4 and then add 3 to both sides, so we get negative 4x minus 5. So either of these is fine. All right, let's try another one. In example 3.2, they ask us to find the equation of a line that is normal to this ellipse. So here's our curve, and they give us the point. So we have a known point. This one is very similar to the last one. They've given us the curve and the point. We're going to use calculus to find the slope. What makes this problem different from the last one is that, of course, we're looking for a line that's normal to the curve and not tangent, but also they gave us an equation that's an implicit function. So we're going to have to use implicit differentiation to find dy dx. Let's start there. So we've got our equation 4x squared plus 9y squared equals 40. And if we differentiate both sides with respect to x, we get 8x plus 18y dy dx equals 0. We can subtract 8x from both sides, and then we get 18y dy dx equals negative 8x, and now we just divide both sides by 18y. So dy dx equals, if we reduce this, let's see, 2, 4 times 9, we get negative 4x over 9. Over 9y. There we go. There's dy dx. Now, we want a normal slope. So the first thing I'm going to do is find the tangent slope. So to find the tangent slope, I'm going to evaluate this derivative at the given point, 1, 2. Notice that because of how the derivative looks, I need both the x and y coordinates this time. So that's negative 4 times 1 over 9 times 2. So our tangent slope is, let's see, 2004 twice, negative 2/9. The normal slope, you know, the normal line is perpendicular to the tangent line. So that means that the normal slope, to find that, we're just going to take the opposite and reciprocal to the tangent slope. For our notation here, for the normal slope, I use a subscript with this sort of upside down t. Like an upside down t is generally what means perpendicular. You might have seen that in geometry, studying geometry. So that's why we use that to indicate the normal slope. So that would be a positive 9/2. Now we know the point. We've got the point they gave us, right? We know our slope. And now we're back where we were in the last problem. At the end, we're going to get the equation of a line. We can use the point slope formula. So that's y minus 2 equals 9/2 times x minus 1. Now you can leave it in this form, that's fine. Or if you want to put it in slope-intercept form, we're going to solve for y. And I'll distribute that 9/2, so we get y minus 2 equals 9/2 x minus 9/2. And then we'll add 2 to both sides. So y is 9/2 x. Let's see, 2 is 4/2, so negative 9/2 plus 4/2 is a negative 5/2. And again, either of these forms is okay. So these two examples that we've done so far are kind of one variety of the problems that we encounter in this section. They'll always give you the curve, right? They'll always tell you, here's the equation of the parabola, or here's the equation of the ellipse, or whatever. Here's the curve we're interested in. And they'll always tell you whether you want a tangent line or a normal line. In the problems that we just did, in these examples, they gave us the point, and we used calculus to find the slope. Now, sometimes they'll tell you the slope, and you're going to use calculus to find the point, and that's what we see happening in example 3.3. So we want to find the equation of the line that has a slope of 4 and is normal to this curve. So they gave us the curve, we know we want a normal line, but this time they gave us the slope. So in the information here, it has a slope of 4 and it's normal. They're telling us that the normal slope, is equal to 4, and so of course we know that means that the tangent slope is equal to negative 1/4. And that means that dy dx, the derivative, is equal to negative 1/4. We know that at the whatever point we're interested in, the derivative is equal to negative 1/4, and we're going to use that to find the point that we need, right? So let's find the derivative of this function. All right, so the function they give us is 1/2 x to the 4th plus 1. So dy dx is 2x cubed. Now they've told us that at the point we're interested in, the derivative is equal to negative 1/4. So So that means that 2x cubed is equal to negative 1/4. We're just setting the derivative equal to this value, and we can find out what x coordinate that happens. So let's divide by 2 or multiply by 1/2. So we get x cubed is negative 1/8. We could take the cube root. The cube root of negative 1/8 is a negative 1/2. So I know the x coordinate of the point. We need both coordinates in order to find the equation of the line though, so now we're going to find that y coordinate. You find a y coordinate by using the original function. We're finding a y coordinate, not a y prime coordinate. So plugging negative 1/2 in for x in the original function, we get 1/2 times negative 1/2 to the 4th plus 1. Negative 1/2 to the 4th is a positive 1/16 times 1/2 is a positive 1/32. Plus 1 is 32/32. And so we get 33/32 for our y coordinate. And that means here we know that our point is negative 1/2, 33/32. So we've used calculus to help us find the coordinates of the point. We knew the slope from the beginning. Our line has a slope of 4. So now let's get the equation of the line. Y minus y1 is equal to m times x minus x1. So we have y minus 33/32 is equal to 4 times x plus 1/2. It's okay to leave it in this form, or you can get it in slope-intercept form. Let's distribute that 4. That's 4x plus 2, and we're going to add 33/32. Two is the same as 64/32, so that is 97/32. And there's the equation of a line. In all of these problems, we're finding the equation of a line. So we know at the end our answer should be an equation where we have just an x to the first and a y to the first. Like, we know what the equations of lines look like, right? We just need the slope and a point to get the specifics. So if you find the equation of a line, if you're doing one of these problems and you get an answer where you have like x squared plus 3x, or 5x cubed minus 7 or something, like, stop. You made a mistake, because that's not the equation of a line, right? Those are curves. Those are like, parabolas or whatever. So just keep in mind that we're using calculus to either fill in one of two blanks. Either they give us the slope and we're using calculus to find the point, like we did in this example here, or they've given us the point and we're using calculus to find the slope that we're after.